Greetings, class. Mr. S back again after a short hiatus. You watched a video from Mr. Wolf on calcium nitrate and sodium oxalate, and you also watched a video from Mr. McGinnis with the magnesium and hydrochloric acid. So now I'm back to kind of hopefully tie all that stuff together and talk about this concept. It's a key concept in stoichiometry, and it's what we're going to concentrate on in part 2 of this chapter, a concept called limiting reactants. Now, one thing you may have noticed from both the calcium nitrate sodium oxalate lab and from demonstration with the magnesium and HCl is that when the amount of reactants are not in the correct proportion, what ends up happening is you don't make the amount of product that you think you might make given the amounts that you've put into either the reaction or in this case, a recipe. And so to demonstrate this idea of limiting reactants and how changing the amount of ingredients can affect the amount of product, I want to relate chemical reactions to recipes because they are very similar. And so to do this, I want to use the recipe for the world famous, not really, S-burger. Now, many of you know that I've been vegetarian for about 20 years now, and so I would have to turn this throwback recipe that I used to make in the old days into, using veggie burgers and things like that and fake bacon. But we're going to go with the original recipe from many years ago. And so the idea behind this is, let's say that finally we get the end of what some of you call coronication or social distancing, and you're finally able to invite some friends over. And you want to invite 9 friends over, and you'd love to make them this fancy S-burger as your meal. So first you got to check out the recipe. And so you see you need 1 onion roll, 2 flame grilled burgers, 2 slices of Swiss cheese, 4 delicious slices of bacon. You got to have a little greenery on there, so there's a piece of lettuce. And then the coup de grace, 3 teaspoons of barbecue sauce. And you put those all together, and all those ingredients will make 1 delicious S-burger or a barbecue bacon double Swiss burger. All right, so based on that recipe, when you want to make 10 S-burgers, you're going to have to figure out how much you have to go out to the store and buy. So let's figure this out. All right, so since you're going to need 10 rolls, 2 burgers per, you have to buy 20 burgers. 2 slices of cheese per, you'll have to buy 20 slices of cheese, 40 bacon, 10 pieces of lettuce, and you'll need 30 teaspoons of barbecue sauce. And again, once you assemble all of these ingredients, you would be able to make 10 S-burgers. And so based on these amounts, your theoretical yield of S-burgers would be 10. Okay, so you're all set, but a problem arises. Your pesky sibling decided the night before you were going to have your friends over that he was getting a little peckish and he wanted a little snack, and looked in the fridge and he saw some bacon and lettuce, and he grabbed a tomato and he said, I'm going to make myself a BLT. And so what he does is he snags 1 of your rolls. He takes 4 pieces of bacon that you had reserved for your S-burgers and he fried those up. And then he threw a couple of pieces of lettuce and he put some tomato, which has nothing to do with the recipe, but he made his BLTs. And so now you get up the next day, right? And you open up the fridge and you're like, hey, who ate the bacon and the lettuce and my roll? I needed to make 10 S-burgers. And so now what you want to figure out is, well, how many S-burgers can you make now once we subtract the number of ingredients that your pesky sibling had for his snack? Let's see. All right, so since he used 1 roll, you now only have 9 rolls. You still have 20 burgers. You still have 20 cheese. You only have 36 pieces of bacon. You're only left with 8 slices of lettuce, but you still have all the barbecue sauce. All right. And so you want to figure out how many S burgers you can make, but you guys know it. You know what you have to do. You kind of look at how many you have, and then how many it takes to make the S burger. And so you have 9 rolls. And so based on the fact you have 9 rolls, well, that could in effect make 9 S burgers. If you look at the 20 burgers and you need 2 per, you could still make 10 S burgers just based on the amount of burgers. You could still make 10 S burgers based on the amount of cheese. Okay, you have 36 bacon. It takes 4 slices per. So just based on the bacon, you could only make 9 S burgers. Oh, you only have 8 slices of lettuce, and it takes a piece of lettuce per. So based with the if you just look at the amount of lettuce you have left, you can only make 8 S burgers. And then finally, with the barbecue sauce, you have plenty of that. You could, in effect, make all 10. Now, you could say, oh yeah, I can still make burgers and just leave lettuce off some and leave bacon off some. But you know what? Then it's not the famous S burger. And so that's what you really want to make. Okay, so how many S burgers could you make? Well, what you kind of got to look at is which number is going to allow you to make the least S burgers, and that would be the lettuce. And so based on these amounts that your pesky brother left you, you can only make 8 S burgers. And so in this case, the theoretical yield would be 8 S burgers. And the ingredient that determined that was the lettuce. Now it's true, you don't have a full complement of bacon or rolls, but the lettuce was even more limiting than the bacon or rolls. And so what we would say that the lettuce was the limiting ingredient, or in chemical terminology, we would say that is the limiting reactant. And you can see that it is the limiting reactant that determines the amount of product you can make. Okay, now finally what we want to look at is this in green. How much of each ingredient would you have left over? Because when you only make 8 S burgers, some of these ingredients are going to have some leftover. And so what we want to do is, based on the fact that we're only going to make 8 S burgers, well, you would only use 8 rolls. And since you would only use 8 rolls, you would have 1 roll left. That would be 1 roll excess. You can only make 8 burgers, and so you're only going to use 16 burgers for your 8 S burgers. And if you use 16 and you have 20, you will have 4 patties left over, 4 hamburger patties. Same with the cheese. To make 8 S burgers, it would take 16 slices of Swiss cheese. You have 20. So 20 minus 16, you're going to have 4 slices of cheese left over. How about bacon? 8 burgers, 4 slices per. You're going to use 32 slices of bacon to make your S burgers, your 8 S burgers. And so again, you'll have 4 slices of bacon left over. How about lettuce? You know what? The limiting ingredient, you're going to have nothing left over. Okay? And that's actually the key for the limiting reactant. The limiting reactant is the reactant that's basically going to run out, because it's the thing that limits how much you can make when it runs out. When you run out of lettuce, you stop the ability to make this delicious S burger. You might be able to make another burger that has less ingredients, but once that limiting ingredient runs out, the making of product stops. And that's a key concept in limiting reactant, which we will visit on the next page. Finally, let's look at the barbecue sauce. Okay, you're going to make 8 burgers. 8 burgers times 3 is 24. You're going to use 24 teaspoons, and so you will have 6 teaspoons of barbecue sauce left. So whereas for all the other ingredients that weren't limiting, you have some leftover. And those ingredients that have leftover, those compounds that have leftovers are going to be called the excess reactant, which is basically the opposite of the limiting reactant. Okay? All right, so there you are. You have everything ready. You get your rolls browned up, you grill your burgers, you have your cheese and bacon fried up, and you're all ready to assemble the 8 burgers that you can now make because your pesky sibling ate a BLT. Well, what happens as you're assembling the burger? So you have the 8 buns laid out, you lay down your burgers, you put on your cheese. When you're ready to put the lettuce, you drop 2 pieces of lettuce on the floor. Now, I know what some of you are going to say, 5-second rule. Well, yeah, but do you really want to, after, how many weeks of isolation, do you really want to serve one of your friends a piece of lettuce that has dog hair on it? Nah. So you only have 6 lettuce. And so what is that going to do? You had an error, okay? There was an error in the, quote, reaction, an error in the assembly of your product where you lost some of the limiting reactant. And what's going to happen is you now only have 6 lettuce. And so that really means that you can still make those burgers without 2 of the burgers without lettuce, but you're really only going to be able to make 6 burgers. Okay. Now, if you think about when we talk about what we talked about before, when we did the where did it go lab with the baking soda and vinegar, we talked about the actual yield as the amount that you can actually make in a chemical reaction, not the theoretical yield. I mean, by stoichiometry, we thought we were going to be able to make 8 burgers, right? Essentially, we looked at the ingredients we had, and we were going to be able to make 8 burgers. But because of an error in the reaction, something happened, we were only able to make 6. And so when we actually assemble our burger, or when we actually do our chemical reaction, we have what's called the actual yield. And in this case, then the actual yield would only be 6 burgers. All right, guys. So when we look at our Where Did It Go lab, Mr. McGinnis's magnesium and hydrochloric acid demo, Mr. Wolf's mole ratio lab, and finally this burger recipe example. What we're going to do is there were some terms that we talked about: limiting reactant, theoretical yield, actual yield. And so what I'd like to do is give you a chance to write these definitions out in your notes. And so we'll do that by video. I'll read them out to you, but then you can always pause the video and then just write out these definitions in your notes. So the first definition we want to talk about is the limiting reactant. Okay, and we're going to use the abbreviation LR. And that, of course, is, as we saw, the substance that controls or limits the amount of product, and the amount of product is always called the yield, that can form in a chemical reaction. We also saw in the example with the lettuce, and actually even in the mole ratio lab, when there wasn't the right amount, and in the MgHCl demo, when there wasn't the right amount of one of the ingredients, one of the reactants, the reaction stopped and no more product was made. You didn't make as much hydrogen gas in the HCl demo as you might have been able to make, or in the mole ratio lab. So when the limiting reactant is used up, again, we saw that with the lettuce, when that is used up, the making of the burgers stopped. So that is our limiting reactant. All right, then we have the excess reactant. Well, the excess reactant is the reactant that is left over once the limiting reactant is used up. And so we're going to abbreviate that ER. And we saw again in the recipe example that all the other items had a leftover, and those were called the excess amounts, or we call those items the excess reactants. And what we're going to find is when one ingredient is limiting, all the other ingredients, all the other reactants will be limiting, will be excess, sorry. All right, so that's excess reactant. So we have limiting reactant, excess reactant. Let's look at three more terms. All right, this term we're familiar with, but I just want to give you a formal definition of it. The theoretical yield, or the TY, we've talked about this before. It is the amount of product determined using stoichiometry, and we determine that with our stoichiometry calculation. All right. The theoretical yield represents how much you would be able to make if the reaction ran perfectly, with no error, with no other reaction happening, with nothing interfering. So stoichiometry, when you calculate the yield of a product, using stoichiometry, you're assuming that there's no error or side reaction. And so that's why we say that that is the theoretical yield. Right? It's a perfect reaction on paper. Now, in a limiting reactant type stoichiometry problem, okay, what do we use to determine the theoretical yield? Well, we saw with the lettuce. The lettuce was our limiting reactant. We couldn't use the amount of bacon to figure out how many S burgers we could make. We couldn't use the amount of burger patties or Swiss cheese or barbecue sauce. We had to use the ingredient that was going to control or limit the amount of product. Again, amount of product is yield. And so the limiting reactant, in a limiting reactant type stoichiometry problem, which we will cover in the next lecture, is all that amount, the amount of limiting reactant is always used to calculate your amount of product that you should make in a perfect reaction. That is the theoretical yield. All right, next term, actual yield, the AY. Well, again, this is the amount of product. We're familiar with this term before. We used it in the Where Did It Go lab. It's the amount of product that's made in a real reaction, one that you actually would do in the laboratory that's filled with error. You know, it's always subject to some kind of measurement error or reaction error, like dropping the lettuce on the floor, dropping some baking soda, on the floor instead of getting it into the beaker from like in the Where Did It Go lab. And you actually measure the amount of product you make. So if you actually do the reaction and you measure the amount of product that you make, it's never going to be as much as the theoretical yield. There's always going to be some kind of error. And so the actual yield, first of all, is always less than the theoretical yield. And in an on-paper stoichiometry problem, right, we're not going to be able to go do the reaction. We're not going to be able to do a real-world reaction every single time like we did with the Where Did It Go lab. And so what's going to happen is I will give you the amount of the actual yield. We'll say something like, oh yeah, the student did this reaction in the lab, and this is how much was actually made. And then what you'll be able to do is compare the actual yield that is given in the problem on paper to the theoretical yield that you will calculate, again, using stoichiometry. Finally, how are we going to compare our actual yield to our theoretical yield? Well, we're going to use a calculation called the percent yield. So the percent yield, again, is that quantity. We're going to calculate it that allows you to compare the actual yield to the theoretical yield. It's a way to kind of judge how efficient the reaction proceeded. And so the percent yield is always going to be, as any percent, a part over a whole. Well, the theoretical yield is how much you should make. That's going to be our whole. The actual yield is going to be the amount we actually made, which again is always less than the theoretical yield because there's always some kind of error that happens. And so that's going to be the part. So it's going to be the part over the whole. And then to turn it into a percent, we multiply by 100. Now to write this out, not in words, but in symbols, what we say is the PY equals the AY over the TY times 100. So let's do a really quick example of calculating percent yield, and let's use our S-burger recipe numbers, okay? Well, when we did our S-burger recipe, what we found was our actual yield, after we dropped the lettuce on the floor, was 6 burgers. Before that, because our pesky sibling had a snack, we could only make 8 burgers. But that was still our theoretical yield with our less ingredients. And then we would multiply that by 100, and we would get 75.0%. And again, usually with percents, we go to one place behind the decimal when we're reporting those, and percent yield will not be any different. We'll just go to one place behind the decimal. All right, guys, so to wrap this up, what are you going to do to practice this concept? Well, you're going to have your very own chance to create your own personalized limiting ingredient recipe. And so you can go ahead and call up the worksheet for this that goes along with this lecture. But basically what you're going to do is you're going to choose, or you're going to make up some kind of recipe, one that you'd want to serve to 10 of your friends to celebrate the end of social distancing. And the only requirement is that the recipe have at least 5 ingredients. Can have more, but it should have at least 5. Then, as I did in the S burger example, write out that recipe as if it were a chemical reaction. Then calculate the amount of each ingredient that you would need to make 10 servings total. So for you and 9 of your friends, write those out as I did in the S burger example. Then imagine that one of your family members used some of those ingredients to make your 10 servings to make a snack. You decide how much they ate and of what ingredients they ate and how much. And then you're going to write out the amount of ingredients you have left, and then determine what the limiting ingredient is and what your theoretical yield is now. And then finally, just as I did in the S burger example, I want you to pretend that when you were making your the number of uh, servings from step 5, that you drop some of that limiting ingredient on the floor. So decide how many that you lost or dropped, and then determine what the actual yield for your recipe is. And so go ahead, call up the worksheet that goes along with this. The worksheet has these directions on them, so you don't have to worry about writing them down. I just kind of wanted to go through what I'm going to ask you guys to do at the end of this lecture. Now, what's coming up next? Well, we're actually going to do some more stoichiometry problems, and all of these stoichiometry problems will include a limiting reactant, and I'll show you what the problem-solving strategy is for that in the next lecture. In fact, it's very similar to regular stoichiometry that we've done before, but there's an additional step that you have to do at the beginning. And in that step, what you'll be doing is determining what your limiting reactant is, and then you'll go ahead, once you determine your limiting reactant, you'll go ahead and do your stoich as usual to determine your theoretical yield. Okay, all right, so get those recipes in, and I'll see you in the next lecture. Toodles, dudes.